Mineral admixtures are finely divided siliceous material which are added to the concrete in relatively large amount. It ranges from 20 to 70% by the mass of the total cementitious material. The power plants using the coals as a fuel are the major source of these byproducts that are produced at a rate of millions of tons every year in many countries. Dumping of this material into landfills and steam of amounts to waste of material will cause serious environmental pollution. The disposal as a concrete aggregate or for the road-based construction is low value, which not only utilizes the pozzolanic and cementitious potential of this material. With the proper quality control, large amount of many industrial byproducts can be incorporated in concrete in a form of blended cements. Whenever a pozzolanic and cementitious byproduct can be used as a partial replacement of cement, it represents a significant amount of cost saving and energy saving. Advantages of using the mineral admixtures. It lowers the rate of the hydration and thermal shrinkages. It increases water tightness. It reduces alkali aggregate reactions. It also improves the workability and lower the cost of the concrete. Pozzolanic reactions. The term pozzolana is the material which has a reactive silica in it. The pozzolana reacts with the calcium hydroxide, forms CHS gel, which is responsible for the compressive strength of the concrete. The concrete which are the mineral admixtures which are commonly used in the concrete are fly ash, GGPS, and generally pozzolana are used as a replacement for the cement. There are two types of pozzolanas, that is naturally available pozzolana and artificially available pozzolanas. Naturally available pozzolanas are the materials that is available on the earth crust. It will be undergo some process to be used as a pozzolana, such as grading, intergraining. The commonly available pozzolanas, natural pozzolanas are volcanic glasses, volcanic tuff, and calcinated clays. These are the examples of pozzolanas: volcanic glasses, calcinated clays, which is nothing but a clay which is heated at high temperature for 2 hours. Diatomic is an amorphous silica which is composed of the skeletal shell from the sea cell walls of the aquatic materials. It is largely deposited in California. Next one is artificial pozzolanas. Artificial pozzolanas are the byproducts of the factories, which include fly ash, silica flume, risers, metakaoline, and surki. Fly ash. Fly ash is finely divided residue resulting from the combustion of the powdered coal, transported by fume gases and collected by an electrostatic precipitator. The fly ash is most commonly used pozzolana all over the world. The importance and use of the fly ash in the concrete has grown so significant, particularly for making high strength and high performance concrete. Utilization of the fly ash as a supplementary cementitious material is a subject of current interest all over the world. This shows the microstructure of the fly ash. We can see the fly ash consists of several smoothly round-shaped particles. The fly ash are used in the construction of dams. The effect of fly ash on the fresh properties of concrete. By using right quantity of fly ash, it will reduce the water demand for the given slump. With the reduction of unit water content, the bleeding and drying shrinkage of the concrete can be reduced. Since the fly ash is not highly reactive, the heat of hydration can also be reduced by replacing the fly ash with the cement. The effect of flares on the hardened properties of concrete. The flares contribute to the strength of the concrete due to its Pozzolanic reaction. However, the Pozzolanic reaction proceeds slowly, hence the initial strength of the concrete is lower when compared to the controlled mix without flares. Due to the continued Pozzolanic activity, the concrete develops a greater strength at a later stage, which exceeds the controlled concrete. The flares concrete should be cured for long enough. In this case, flares concrete can be used in underwater structures such as dam, which will derive the full benefit of attaining improved longer strength and water tightness. Durability of the concrete. Since sufficiently cured concrete containing good amount of layers shows a dense structure, which will has a highly resistivity to the infiltration of the deciduous materials. It also recognizes that addition of layers contribute to reduction in the expansion of the alkali and aggregate reactions. The high volume fly ash is that concrete which has 50 to 60% of fly ash incorporated in it. It was first developed for the mass concreting where low heat of hydration is of main importance. Due to the low water content of the high volume fly ash, use of plasticization became necessary and use of air entering agents are commonly used. The next one is silica fume. Silica fume refers to as microsilica or condensed silica, which is used as another silica fume The next one is silica fume. Silica fume, also referred as microsilica or condensed silica, is another material that is used as an artificial pozzolana in concrete. It is a byproduct resulting from the reduction of high purity quartz with coal in electrolytic arc furnace, the manufacture of silicon or ferrosilicon alloys. Silica fume rises as an oxidized vapor. It cools, condenses and collected in the cloth bags. It is further processed to remove the impurities during its production. The condensed silica is essentially a silicon dioxide in non-crystalline form. This figure shows the silica fume. If we see into the morphology of the silica fumes, it will look as a cohesive material. The influence of silica fume on the fresh properties of concrete. It will increase the water demand in the concrete. Increase in water demand is of range from 1% for every 1% substitution of cement. Therefore, 20 mm size aggregate containing 10 mm silica fume will have an increased water content of about 20 liters per meter cube. The measure has been taken to avoid this increase by adjusting the aggregate grading or using the superplasticizer. The addition of microfill will reduce the slump, but because of its cohesive nature, as we seen in the micro structure of the silica fume, it is found there is a large reduction in bleeding, and concrete with a microsilica can be handled and transported without segregation. It is also reported that the concrete containing microsilica is vulnerable to plastic shrinkage cracks, and therefore sheet or mat curing should be required. The influence of the hardened concrete. The concrete containing microsilica shows an outstanding strength in the development of concrete. It is found that the modulus of elasticity of the silica concrete is less than that of the concrete without silica. The next one is rise stress. Rice husk is obtained by burning the rice husk in controlled manner without causing an environmental pollution. When properly burned rice husk, it has a high amount of silicon dioxide and can be used as an admixture. The rice husks exhibit higher pozzolanic characteristics and contribute to high strength and impermeability of the concrete. In India, about 122 million tons of paddy were cultivated every year. Each ton of paddy produces 40 kg of rice husk ash. This can be used as a potential pozzolanic material to almost give the same amount of microsilicas. It's an image of the rice husk ash. The next one is Shruki. Shruki is the most commonly used pozzolanic material in India. Shruki is an artificial pozzolana made by powdering the bricks or burned clays. In some major works, a large scale of Shruki or clay balls are used or specially burned for these purposes, and they are powdered and used in the concrete. By its nature, it is a complex material differing wide variety in qualities and performance. Because of its constituents like minerals, degree of burning, and fineness of the graining. Because of the complexity of these problems, there is always a much confusion on the account of results obtained by various research workers. This shows the image of Shruki. Shruki, which is burned at higher temperature, forms metacaolines. They are also called as calcinated clay pozzolana. It is used instead of Shruki's. Shruki has been used in the construction of the Bakarangal Dam. The next one is GGBS, which is known as ground granulated blast furnace slag. It is a non-metallic product consisting essentially of silica and alumina of the calcium and other bases. The molten slag is repeatedly chilled by squashing in the water to form a glassy sand like granulated materials. These granulated materials further grounded or intergrinded to less than 45 microns to have a specific surface area of about 400 to 600 meter square by kgs. The performance of the slag largely depends upon its chemical composition, glass content, and fineness of graining. The figure shows the image of the GGBS. There are two methods of making the GGBS. That is blast cement. First one, the slag is interground with the cement clinker along with the gypsum. The second one is blast slag can be separately added during the mixing of the concrete. The performance of the GGBS in concrete. The replacement of the cement with slag will reduce the water content to some extent. This reduction in the water content will predominantly due to the increase in the slag content, which depends upon the fineness and grading of the slag. In addition to water reducing, the surface of the slag is slightly slower than the cement. Hence, it reduces the heat of hydration. It refines the pore structure of the concrete. It reduces the permeability